Gonna do more examples of areas of polygons. So first one I'm going to do is I'm going to do different examples of equilateral triangles. So think about an equilateral triangle and then you're given a side length is 10. Then I'm going to do one where you have an equilateral triangle and you're given the radius is 10. Then I'm going to do an equilateral triangle and you're given that the apothem is 10. So there's three different situations that you could have. So the first one, if you have all side lengths 10, then we can use area equals, you can either use 1/2 base times height or 1/2 apothem times perimeter. It doesn't matter. I'm actually just going to do 1/2 base times height for this. So I need to drop down this perpendicular. So this is a 60 triangle, so it's going to be a 30, 60, 90. This is 60. So this short side has to be 5, and so this has to be 5√3. So the area is 1/2 the base, which is 10, and the height is 5√3 because of special right triangles. So I want to leave this as exact. So this is going to be 1/2 of 10 is 5. 5 times 5 is 25. So it's 25√3 units squared. That's one example. And then what if you have the radius? So the radius goes to the center. So I'm going to go ahead and draw in the other radii. Now this triangle right here, this has to be 120 degrees because all three of these are 120 degrees to be 360. So you can drop down, this is going to be a 60-degree angle. So if I drop that down, this is the short side, this is 5. So the apothem is 5, and this is 5√3, which makes all the way across 10√3. So you could do, if you wanted to, you could either do area is 1/2 base times height, so height base, the base would be 10, the height would be 10 plus 5, so the height was 15, and this is 10√3, or you could do 1/2 AP. So I'm just going to do 1/2 AP because we haven't done that yet. So 1/2 apothem times perimeter. So area is 1/2 the apothem, which is 5, times the perimeter. So the perimeter is going to be 10√3, and there's 3 of these. So it's 10√3 times 3. So to clean this up, it's 5 times 10 is 50. 50 times 3 is 150. Divided by 2, because that's 1/2, is 75√3 units squared. So you could have a side length, you could have the radius be 10, or you could have the apothem be 10. So let's do this one. Again, this is going to be a 30, 60, 90. So this side has to be 10√3, which makes this whole side 20√3. So I'm going to use area equals 1/2 apothem times perimeter. Area is 1/2 the apothem, which is 10, times the perimeter, which is 20√3, and there's 3 sides. So at the end, I'm going to do 20 times 3 is 60. 60 times 10 is 600. 600 divided by 2 is 300√3 units squared. So this is equilateral triangles. Okay, now I'm going to do, let's do pentagons. So I'll do different situations with a pentagon. So pretend that you have a pentagon that's regular, and you're given the radius is 10. And then we'll do a pentagon that's irregular, and we'll give a side length that's 10. Then we'll do a pentagon, and we'll do the apothem that's 10. And we'll go through what it looks like for all these different situations. So we're going to use 1/2 the apothem times perimeter. So I'm going to drop this down. I need to figure out this blue segment for the apothem, and then I need to figure out this for the perimeter. So it's going to be 1/2 the apothem, which this is not a special right triangle because this is not a 30, 60, 90. So to figure out the degrees, I do 360 divided by 5, which is going to get me this angle. And then I cut it in half. So that's 72, but then I cut it in half, so that's 36. So this is 36. So to figure out the blue side, I'm going to use cosine. So the cosine of 36 equals a over 10. So 10 cosine of 36 equals a. So that's going to be my apothem. So 10 cosine of 36. Now I have to do the perimeter. So the perimeter I'm going to solve for x. I'm going to use trig again because it's not a special right triangle. So I'm going to do the sine of 36 equals x over 10. So x equals 10 sine of 36. So to find the perimeter, I'm going to do 10 sine 36, but it's a pentagon, so there are going to be 10 of these. There's 5 sides, but each of these is cut in half. So times 10. So here's my calculation for the area of that one. Okay, then I'm going to do a pentagon with a side length of 10. So we need the apothem. We know this is 5. We already know that this is 36 degrees. We need to figure out what the apothem is. So I'm going to use tangent. So the tangent of 36 equals opposite 5 over a. So the apothem is 5 divided by the tangent of 36. So now I do the perimeter. A equals 1/2 the apothem, which is 5 divided by the tangent of 36, times the perimeter. So the perimeter, the side length is 10, so the perimeter is 50. So you multiply all of these and round. Okay, put this all in your calculator at once. So I don't want to put the 5 divided by tangent of 36 in my calculator yet until the very end because I don't want to round and round. So let's see, in the last one, the apothem's 10. So I need to figure out this to find my perimeter. So area equals 1/2 the apothem times perimeter. So area equals 1/2 times 10 times the perimeter. Okay, again, we know this is 36 degrees. So to figure out what x is, I'm going to use tangent. So the tangent of 36 equals x over 10. So x equals the tangent of 36 times 10. I'll put 10 tangent 36. But there's going to be 10 of these around the outside. So the perimeter is 10, because there's 10 sides, 10 of these x's, times 10 tangent 36. So just like we did equilateral triangles, there's all these different situations that you could have. You could, if you know the radius, it's totally different than doing the apothem, or the side length, which is totally different than the apothem. So you have to look at each triangle individually, whether it's a special right triangle or if you use trig.